So hello students, how are you? I hope you are all doing well. So today we will start with another chapter, that is polynomials. This is the second chapter of your class 10 mathematics. So we'll start with class 10 second chapter, that is polynomials. So first we will be starting with the definition. What is a polynomial? Okay, so polynomial, what we can say is that polynomial is an algebraic expression. Polynomial is an algebraic expression whose variable's power is a whole number. The power of a variable is a whole number. Okay, so what we can say is a polynomial, okay, is an algebraic expression whose variable's power is a whole number. An algebraic expression whose power is a whole number, we call it as polynomial. For example, consider an algebraic expression 8x plus 3. So consider an algebraic expression 8x plus 3. If we consider 8x plus 3, the power of x is 1, which is a whole number. Similarly, if I consider second algebraic expression 6x square plus 5x plus 4y, here also the power of the algebraic expression is, here x power is 2, here the power of x is 1, here the power of y is 1. All are whole numbers. So I think you are familiar with whole numbers, that is whole number starts with 0, 1, 2, 3 and so on. These we call it as whole numbers. So all these are whole numbers. So consider the algebraic expression 8x plus 3, the power of the x is 1. In the second expression the power of x is 2, here the power of x is 1, here the power of y is 1. Similarly, if I consider the third algebraic expression, here the power of x is minus 1, which is not an whole number. Therefore, this is not a polynomial. So the first one is a polynomial because the variables power, variables are alphabets like x, y, so on. So the power of x here is 1, therefore it is a algebraic expression and also it is a polynomial. The second one, every variable has a power which is a whole number, that is x raised to 2, x raised to 1, all are whole numbers, therefore it is a polynomial. But in the third case, in this algebraic expression, the power of x raised to minus 1, the power of x is minus 1, which is not an whole number, therefore this is not a polynomial. But this is an algebraic expression, but this is not an whole number. Similarly, if I go to the next example, consider the next example. Here the example is x square plus 1 upon x raised to 3. Here if I consider the power of x is 2, here the power of x is 3. No doubt it is 3, but after simplification I can write this as x square plus 1 upon x raised to 3 can be written as x raised to minus 3. 1 upon x raised to 3 can be written as x raised to minus 3. So therefore x raised to minus 3, the number minus 3 is again not a whole number. The number minus 3 is again, it is not an whole number. Okay, the number minus 3 again, it is not an whole number. Therefore this expression, algebraic expression x raised to 2 plus 1 upon x raised to 3 is not a polynomial. If I go for next example, x raised to 3 by 2 divided by x raised to 1 by 2. X raised to 3 by 2 divided by x raised to 1 by 2. Again, if I simplify this, x raised to 3 by 2. So using the law of exponents, if I take 1 by 2 to the numerator, so then I can write it as x raised to 3 by 2 minus 1 by 2. Using the law of exponents, a raised to m divided by a raised to m is a raised to m minus 1. Therefore, x raised to 3 by 2 minus 1 by 2, it forms x raised to, okay, denominator is same, therefore I can write 3 minus 1 as 2 divided by denominator is 2, 2 to cancel, it forms x raised to 1. It forms x raised to 1. Again x raised to 1 is a whole number. Again x raised to 1 is a whole number, therefore this is a polynomial expression. So basically the definition of polynomial is, it is an algebraic expression whose variable's power is a whole number. So we can call an algebraic expression as a polynomial only when the power of the variable is an whole number. Suppose if it is not a whole number, then we cannot call an algebraic expression as a polynomial. We have seen some of these examples. Out of these 5 examples, the first one is a polynomial, the second one is a polynomial, third one is not a polynomial because it is not an whole number. Similarly, if I go for fourth example, 1 upon x raised to 3 can be written as x raised to minus 3, which is again not a polynomial because minus 3 is not a whole number. Similarly, in the fifth case, where x raised to 3 by 2 divided by x raised to 1 by 2, after simplification, we will get that x raised to 3 by 2 minus 1 by 2, where it is x raised to 2 by 2. After simplification, we will get the power of x as 1. So after simplification of this, we are getting the power of x as 1, which is again a whole number. Therefore, the last one is a polynomial. Okay. So some more examples. So what about this expression, whether it is a polynomial? So definitely this expression is also not a polynomial because root x means x raised to 1 by 2, which is not a whole number. Root x means x raised to 1 by 2, again it is not a whole number, therefore this is not a polynomial. Okay. If I go for the next example, again the power of x here is 1 by 3, which is not an whole number. Therefore, this is also not a polynomial. So in the previous example, we saw that root x means x raised to 1 by 2. 1 by 2 is again, it is not a whole number. Therefore, this is not a polynomial. Similarly, x raised to 1 by 3 plus 2x square plus 5y plus 3, here the power of x is 1 by 3, which is again not a whole number. Therefore, this is not a polynomial. So by this we can conclude that we can conclude that we can say a sentence, or we can conclude with this standard sentence where we can say that all polynomials are algebraic expressions. All polynomials are algebraic expressions, but all algebraic expressions are not polynomials. All polynomials are algebraic expressions. No doubt all polynomials are algebraic expressions. But all algebraic expressions, they cannot be polynomials, because algebraic expressions can be polynomials only when the power of the variable is a whole number. That is a condition. An algebraic expression to be a polynomial, the power of the variable should be a whole number. Therefore, this is a standard sentence we say in mathematics, that all polynomials are algebraic expressions, but all algebraic expressions are not polynomials. Okay. So we can go to the next topic, that is types of polynomials. So types of polynomials can be classified based on the number of terms and also based on the degree. So based on the number of terms, if there is simply one term, then we can say it as a monomial expression. If there are two terms, we can say that binomial expression. If there are three terms, we can say that a trinomial expression. So if there is one term, we can say that monomial. If there are two terms, we can say that binomial. If there are three terms, we can say that trinomial. So monomial, binomial and trinomial. There are three variety of expressions. So if there is one term, monomial, two terms, binomial, three terms, there are trinomial. If there are many terms, which we call it as obviously polynomial. Next, based on the degree, based on the terms, based on the number of terms, we have three categories. And based on the degree, what is the degree? Degree means, suppose if I consider a polynomial like x square plus 4x plus 5, okay, here the highest power of a variable is 2. Here the highest power of a variable is 2, which we call it as a degree. Therefore, I can say that x square plus 4x plus 5, this is a polynomial with degree 2. This is a polynomial with degree 2. Okay. So there are many categories based on what we can say that based on the degrees. Based on the degree, we can categorize polynomial into 4 or 5 varieties. First one is linear polynomial. Linear polynomial is something like x plus y is equal to 4. X plus y is equal to 4, where the highest power of a variable is 1. If the highest power of the variable is 1, then we can say that it is a linear. If the highest power is 2, for example x square plus 4x plus 4, if the highest power of the variable is 2, then we can say that it is a quadratic. Similarly, cubic, if the highest power of the polynomial is 3, for example, this is an expression where the highest power of the variable is 3, which we can say that cubic. Similarly, biquadratic refers to highest power as 4. For example, x raised to 4 minus 16 equal to 0. Okay. So this is the highest power with 4. So these are all examples of linear, quadratic, cubic and biquadratic. Similarly, we have another two categories. Okay. The last two categories, which we can say that constant polynomial and zero polynomial. So what is a constant polynomial? Constant polynomial is something like constant numbers. For example, 2. Here we don't have a variable, but we can write a variable. We can write 2 as 2x raised to 0. We can write 2 as 2x raised to 0 because x raised to 0 stands as 1. The value of x raised to 0 is 1. So therefore we can write 2 as 2x raised to 0. Suppose if there is a number called as 100, how can we write 100 in terms of polynomials? We can write 100 constant as 100x raised to 0. So we can write any constant as constant into x raised to 0. Therefore, the degree of the constant polynomial is always 0. The degree of the constant polynomial is always 0. We can write any number as, for example, if the number is 1000, we can write 1000 as 1000 into x raised to 0. Okay, we can write any polynomial with the help of we can write any constant with the help of x raised to 0. Therefore, the degree of any constant polynomial will be 0. Okay. And the next one is zero polynomial. What is zero polynomial? So zero polynomial is just writing numbers as 0. For example, if I consider the number 0, how can I write 0 as a polynomial? I can write 0 as a polynomial as 0 into x raised to 1. Or I can write 0 as 0 into x raised to 100. Or I can write 0 as 0 into x raised to 20. Or I can write 0 as 0 into x raised to 5. So we all know that suppose if I multiply any number with 0, suppose if I multiply anything with 0, the answer will be 0. Therefore, I can write 0 into x raised to with any power. I can write 0 into x raised to 1, I can write 0 into x raised to 20, I can write 0 into x raised to 100, or I can write 0 into x raised to 5, or I can write 0 into x raised to 500. So anything which is multiplied by 0 will again be 0. Therefore, while writing 0 as a polynomial, we can raise the power of x to any number. Therefore, the degree of a zero polynomial is not defined. The degree of the zero polynomial is not defined because we can write the power of x as any number. Okay. So therefore, the degree of the polynomial is not defined. Okay. So these are the types of polynomials. Based on the terms, we have 3 terms: monomial, binomial and trinomial. Based on the degree, we have linear, quadratic, cubic, biquadratic, constant and zero polynomial. Okay. So for a linear polynomial, we have a degree 1, quadratic we have a degree 2, cubic we have a degree 3, biquadratic we have a degree 4, and for a constant polynomial, it is always having a degree as 0, and for a zero polynomial, degree is not defined. Why it is not defined? Because the power of x can be anything. It can be written as 1, it can be written as 20, it can be written as 100, or it can be written as 500. Anything can be raised to the power of x when the number is 0. Therefore, the degree is not defined for a 0 polynomial. Next important topic is value of the polynomial. How do you find the value of the polynomial? For example, here it is given as f of x equal to 7x plus 8. So how do you find the value of the polynomial? Simple. So for example, you are interested in finding f of 1. So what is the meaning of f of 1? What is the meaning of f of 1? F of 1 indicates that when you take x value as 1, what will be the answer? When you take x value as 1, what will be the answer? That we call it as value of the polynomial. For example, they have given an expression that f of x equal to 7x plus 8. So we have to find f of 1. We have to find f of 1. F of 1 meaning when the value of x is 1, what will be the answer? So when the value of x is 1, what will be the answer? That we call it as value of the polynomial. For example, how do you find the value of the polynomial? Simply, we have to put x equal to 1. So in this algebraic expression, wherever there is x, you substitute x with 1. So what will be the answer? 7 into, substitute the value of x as 1, 7 into 1, 7 into 1, 7 plus 8. So what is the final answer? The answer will be 15. So this is the value of the polynomial when x is equal to 1. Okay. Similarly, when x is equal to 2, what is the value of this polynomial? When x is equal to 2, what is the value of the polynomial? That is, f of 2 is equal to how much? So if you are interested in finding f of 2, then simply put the value of x as 2. So wherever there is x, put the value x as 2. 7 into 2 is 14. 7 into 2 is 14. 14 plus 8. So what is 14 plus 8? It is 22. Okay. So these we call it as value of the polynomial. So what is value of the polynomial? Value of the polynomial is when you substitute the value of x into any number 1, 2, 3 or any integer or any other variable, then what is the answer you are getting? That answer we call it as value of the polynomial. Next important topic is zeros of the polynomial. What is zeros of the polynomial? Zeros of the polynomial means, what is zero of a polynomial? Zero of a polynomial indicates what is the value of a variable. The value of a variable which makes polynomial value as 0. What is the value of x? Here the variable is x. So for what value of x, this expression will be 0. For what value of x, this whole expression value will be 0. So the simple question is f of x equal to x plus 8. So if I for what value of x, this whole expression becomes 0. For example, if I take x value as 1, what is the answer? 1 plus 8, it will be 9. If I take x value as minus 1, then 8 minus 1 will be 7. So similarly, if I take x as minus 8, then the value of minus 8 plus 8 will be 0. The value of the polynomial will be 0. So the value of the polynomial becomes 0 when x is equal to minus 8. So when x is equal to minus 8, the value of the polynomial becomes 0. So this we call it as 0 of the polynomial. Therefore minus 8 becomes 0 of the polynomial. I hope you are all understanding what is zeros of the polynomial. 0 of the polynomial is, it is the value of the variable which makes polynomial value as 0. Okay, in simple terms, so what should I substitute in x? To get the answer as 0? That substitution we call it as 0 of the polynomial. For example, in this case, f of x is equal to x plus 8. So I have substituted x as minus 8. If I substitute it as x as minus 8, then the answer will be 0. So for what value of x the answer was 0? The value of x was minus 8. Therefore this minus 8 we call it as 0 of the polynomial. Okay. So next, number of zeros of a polynomial. For a linear equation we have only one zero. For a linear equation we will be having only one zeros. For a quadratic equation we will be having two zeros. For a cubic we will be having 3. For a constant polynomial does not have any 0. Constant polynomials does not have any 0. Okay. Next, what is the geometric meaning of zeros of a polynomial? What is the geometric meaning of zeros of a polynomial? So suppose if I take an example of a linear equation, x minus y is equal to 0. This is an example of a linear equation. I can write x minus y equal to 0 as y equal to x. Minus y, take it on the right hand side, it becomes plus y. Therefore plus y is equal to x, or y equal to x. Suppose if I plot a graph using this. Suppose if I plot a graph using this x, y. If I take x as 1, y will be 1. If I substitute x as 2, y will be 2. X as 3, y will be 3. X as 0, y will be 0. X as minus 1, y will be minus 1. X as minus 2, y will be minus 2. And x as minus 3, y will be minus 3. Suppose if I substitute the values of x and y in a graph, x and y, minus x axis and negative y axis. Suppose if I substitute all the points, so 1, 2, 3, 4, 1, 2, 3, 4, this is origin 0, this is minus 1, this is minus 2, this is minus 3, minus 1, minus 2, minus 3. Suppose if I substitute all these values, okay, for 1 I should substitute as 1, for 2 answer is 2, for 3 answer is 3, for 4 answer is 4. Similarly for 0 it is 0, for minus 1 it is minus 1, for minus 2 it is minus 2. So I have got around 5-6 points. If I join all these points, I will be getting a straight line. I will be getting a straight line which is passing through the x-axis, or which is touching the x-axis. So the geometric meaning of a zeros of a polynomial is, if a polynomial has a 0, then it will definitely touch the x-axis. Based on this geometrical diagram, we can figure out how many number of zeros are possible and what are the zeros. So how do you find number of zeros? Just by observing the diagram. So how many times does the graph touches the x-axis? Based on that we can figure out that how many number of zeros are possible. For example, this particular graph which I have drawn, y equal to x, this is touching the x-axis just at once. So this line is touching the y-axis, this line is touching the x-axis just once. Therefore the number of zeros is 1. Suppose if it is touching the x-axis 2 times, then the number of zeros will be 2. And how do you find the zeros? It is easy that where does the graph touching the x-axis? For example, if a line is passing through this point at the point x equal to 2, so suppose if the line is passing through the point 2 on the x-axis, then the value of the zeros is 2, x equal to 2. And how many times the line is passing through the x-axis? Just one time. So the value of zeros, so the number of zeros will be 1. Okay, and how do you find the zeros? Just by observing the point where does the line touching the x-axis, that is 2. So here are some examples where we can understand how do you find the zeros and how many zeros are possible. First graph, if I consider the first graph, this graph is touching the x-axis just at this one point. This graph is touching the x-axis just at this one point. Therefore, the number of zeros is 1. If I consider the second graph is touching the x-axis at 2 points. Therefore, the number of zeros is 2. The third graph, if I consider this graph is touching the x-axis at 3 points. This is the first point, this is the second point, and this is the third point. Therefore, the number of zeros is 3. And the next graph, which is touching the x-axis at just 1 point, the number of zeros is 1. And the next graph, which is touching the x-axis at just 1 point, therefore the number of zeros is 1. And the last graph, which is touching the x-axis at 4 points, 1, 2, 3 and 4. Therefore, the number of zeros is 4. Therefore, the number of zeros is 4. Okay, hope you are all understanding. Next, we can move on to the next topic, graphs of the polynomials. Linear polynomial. For a linear polynomial, number of zeros will always be 1. For example, if I consider f of x equal to 8x minus 7. So, how do you find the zeros of this polynomial? Simply 8x minus 0 equated to 0. We will get 8x is equal to 7 and x is equal to 7 by 8. This is the 0 of that polynomial. This is the 0 of that polynomial. Remember that for a linear polynomial, number of zeros will always be 1 and the graph will always be a straight line. And the graph will always be a straight line. The graph of the linear polynomial will always be a straight line. And how do you find the zeros? Simple. The given algebraic expression or a linear polynomial, it should be equated to 0. And then simplify, you will get the value of x, which indicates the 0. The value of x indicates the zeros. Okay. Moving on to the next topic. Graph of the quadratic polynomial. Consider the graph of the quadratic polynomial as given in this figure. So here is an expression f of x equal to x square plus 4x plus 4. So write down the values of x as 1, 2, 3, 4, 5, so on. Many values you can take as much as you want. And substitute in this expression. Substitute the values of x 1, 2, 3, 4, 5 in this given equation. You will get the values of y. For the corresponding values of x, you will get the corresponding values of y. Then just simply plot the graph. We will get many points. Okay. And depending on the number of points, you just draw the graph. After drawing the graph, just observe how many points are on the x-axis, or the graph is touching the x-axis how many times? How many times does the graph touching the x-axis? Just observe how many times does the graph touching the x-axis. So after observing, we can make out that the graph is touching the x-axis twice. So here is 1 point and here is 1 point. Okay, these 2 points where the graph is touching the x-axis. Therefore, the number of zeros of a quadratic here is 2. In some cases, the number of zeros of a quadratic equation might be just 1. Observe this diagram. Here is a parabola where it is touching the x-axis just once. In some cases, the number of zeros of quadratic polynomial can just be 1. And in some cases, it might also be 0. For example, this is a parabola. Okay. Remember, the graph of the quadratic polynomial will always be a parabola. Parabola means the shape, the curve in this shape, which we call it as a parabola. The graph of the quadratic polynomial is always a parabola. The graph of the quadratic polynomial is always a parabola. So the parabola can cut the x-axis in 2 positions, or it can cut the x-axis in just 1 position, or it might not cut even a single point on the x-axis. There are 3 possibilities. If the parabola cuts the x-axis at 2 points, then the number of zeros will be 2. If the parabola cuts the x-axis at just 1 point, the number of zeros will be just 1. If the parabola doesn't cut the x-axis or doesn't touch the x-axis at any point, then the number of zeros will be 0. It means no zeros in that polynomial. There are three cases in this quadratic equation format. The number of zeros might be 2, or it might be 1, or it might be 0. Okay. Next, how do you find the zeros of a quadratic polynomial? Next, how do you find the zeros of the quadratic polynomial? It is simple. So, for example, there is a quadratic equation x square minus 36. So, how do you find the zeros of the quadratic polynomial? Simple. Equate x square minus 36 is equal to 0. Then, therefore, x square is equal to 36. Therefore, x is equal to root of 36, which is equal to x square is equal to plus or minus 6. So, there are two possibilities, plus 6 and minus 6. These are the two zeros. These are the two zeros, or these are the two roots of the polynomial. These are the two zeros, or these are the two roots of this polynomial. Okay. Similarly, x square minus 49 equal to 0. So, equate x square 49 is equal to 0. Therefore, x square will be equal to 49. X is equal to plus or minus 7. So that there are two roots. One is plus 7 and another is minus 7. These we call it as zeros of the polynomial. These we call it as zeros of the polynomial x square minus 49, or we can also call it as roots. We can call them as zeros, or we can also call them as roots. Usually in mathematics we represent these roots as, if we get two roots, we represent these two roots as one as alpha and another as beta. So usually we represent these roots as one as alpha and another as beta. Okay. So next, how do you solve this quadratic equation? So the standard equation of a quadratic equation is something like this. The standard equation of a quadratic equation is something like this: ax square plus bx plus c. So how do you find the roots of this equation, that is x square plus 4x plus 4 is equal to 0? How do you find the roots of this equation, or how do you find the zeros of this equation? First thing, we have to equate it to 0. X square plus 4x plus 4, we have to equate it to 0. Okay. So next we have to split the middle term. Next we have to split the middle term. For example, what is the middle term? That is 4x. We have to split the middle term. To split the middle term, there are if we add, the number should be 4. If we multiply, then also the number should be 4. If we add, then also the number should be 4. What are the two magical numbers? When we multiply, the number should be 4, and when we add, then also it should be 4. So we know that 4 has many factors. It has 1, 4, and it has 2, 2. 1 4s are 4, 2 2s are 4. So which among these factors, which are the factors which satisfy this condition? I think 2, 2. So therefore we can split x square plus 4x plus 4 as, we can split x square plus 4x plus 4 as x square plus 2x plus 2x plus 4. So that if we multiply, we will get the answer as 4, and if we add, the answer will again be 4. So 2 2s are 4, and 2 and 2 if we add, we again get it as 4. So take x as common, we will get x plus 2, plus 2 as common, we will get x plus 2. Therefore, we can write it as x plus 2 equal to 0, or x plus 2 equal to 0. Therefore, the value of x is minus 2, or x is equal to minus 2. So how do you split the quadratic equation? So we can solve this quadratic equation by splitting the middle term. What is the middle term? Middle term is 4x. We should split the middle term so that the product of the two numbers should be 4 and the sum of the number should be 4. So by this condition we split this quadratic equation and we got the roots as minus 2 and minus 2. These roots we can also call it as zeros. So the zeros of the quadratic equation are minus 2 and minus 2. So we will move on to the next example. The next example is x square plus 5x plus 6. So what is, write the standard format of the quadratic equation, ax square plus bx plus c. So what is the value of c? It is 6. What is the value of a? That is 1. So multiply a into c. A into c will be 6. And what is the middle term? Middle term is 5. Middle term is 5. So now the condition is, if we multiply, the answer should be 6. If we multiply two numbers, the answer should be 6. And if we add two numbers, the answer should be 5. Choose two numbers so that the product of the numbers is 6 and the sum of the numbers is 5. Using those numbers, we can split this middle term. So we can split the middle term of the expression x square plus 5x plus 6 equal to 0. Split the middle term so that the product of the two numbers should be 6 and the sum should be 5. Split the middle term so that the product of the numbers should be 6 and the sum is 5. So what we can write is x square plus 5x plus 6 equal to 0. We can split the two numbers as 2x plus 3x. Because if we add 2 and 3, the answer will be 5. If we multiply 2 and 3, the answer will be 6. Therefore, we have split the middle term 5x as 2x and 3x. Because the condition is, if we multiply, the answer should be 6. That is 2 3s are 6. And if we add, the answer should be 5. That is 2 plus 3 is 5. So x square plus 2x plus 3x plus 6 equal to 0. We have split the middle term 5x as 2x plus 3x. So the next step is we have to take the common numbers. X square plus 2x, x is common. So x plus 2. And in 3x plus 6, take 3 as common. We will be left with x plus 2. So the next step is x plus 2 into x plus 3 is equal to 0. So if x plus 2 is equal to 0, x will be equal to minus 2, or x plus 3 equal to 0, we will be having x is equal to minus 3. So the answer which we got, we call it as zeros of the quadratic equation. We can call them as zeros of the quadratic equation, or we can call them as root of the quadratic equation, or we can represent these using symbols alpha and beta. Alpha and beta represents the zeros or the roots of the quadratic equation. Okay, we will move on to the next problems. So there is another question here, x square plus 4x minus 21. So compare this with standard format ax square plus bx plus c. So what is the value of c? The value of c is minus 21. And what is the value of a? The coefficient of x square is 1. Therefore the value of a becomes 1. So multiply a and c. That will be equal to minus 21. Okay. And what is the middle term? What is the b? What is the value of b? The value of b is 4. The value of b is 4. So how do you solve this equation? How do you solve this equation x square plus 4x minus 21 equal to 0? How do you solve this equation? We can solve this equation by splitting the middle term. So we can solve this equation by splitting the middle term. But the condition is we have to split the middle term such that the product of the number should be 21 and the sum should be 4. The sum should be 4 and the product should be 21. So choose two numbers such that the product of the numbers is minus 21 and the sum is 4. So therefore x square plus 4x minus 21 equal to 0. X square plus 4x minus 21 equal to 0. We have to split the middle term such that the product should be minus 21 and the sum should be plus 4. So I can take numbers as 7x minus 3x. 7x minus 3x minus 21 equal to 0. 7 minus 3 is plus 4. 7 minus 3 is plus 4. And 7 into minus 3 is minus 21. And 7 into minus 3 is minus 21. See that 7 into minus 3 is minus 21. 7 into minus 3 is minus 21, and 7 and minus 3 if I add, then we can get 4. Therefore, I have split this middle term 4x as 7x and minus 3x. So x square plus, okay, what is the next step? In x square plus 7x and minus 3x minus 21, take out the common factors. So out of x square plus 7x, we can take x as common. Therefore, x plus x is common. We can write x as x plus 7. We can write, by taking x as common, we can write it as x plus 7. Take minus 3 as common. Again, we can take, we are left out with x plus 7, okay, equal to 0. Therefore, the next step is x minus 3 is equal to 0, or x plus 7 is equal to 0. Therefore, x is equal to 3, or therefore x is equal to minus 7. Therefore, x is equal to minus 7. Okay. So this is one simple example where we have to solve this quadratic equation, or we have to find the roots of the quadratic equation. That is, we have to find alpha and beta by splitting the middle term. The condition was the product should be minus 21 and the sum should be plus, and the sum should be plus 4. So we have to choose two numbers so that the product should be 21 and the sum should be 4. The numbers were 7 and minus 3. Because 7 into minus 3 is minus 21 and 7 minus 3 is 4. Then we have split the middle term. Then we have taken the common factors and then we simplified, we got the roots. So next category questions are, find the zeros of the polynomial and verify the relationship between the zeros and coefficient, and verify the relationship between the zeros and coefficients. Okay. So this is one quadratic equation they have given. X square minus 2x minus 8. Let us first find the zeros, then we can later verify the relationship between the zeros and coefficient. So x square minus 2x minus 8, let us find the zeros. X square minus 2x minus 8 equal to 0. So what is the condition? What is the condition? If we multiply minus 8 into 1 is minus 8. Therefore, if we multiply, we should get as minus 8 and the sum should be minus 2. The sum should be minus 2, and if we multiply, we should get minus 8. Which are the two numbers? So the numbers are simple. X square minus 4x plus 2x minus 8 equal to 0. The numbers are minus 4 and 2. Minus 4 into 2, if we multiply, we will get minus 8. Minus 4 into 2, if we multiply, we will get minus 8. And minus 4 and 2, if we add, we will get it as minus 2x. Okay. Therefore, by splitting the middle term, minus 2x as minus 4x plus 2x, we can solve this equation, because it satisfies the condition that if we multiply, we will get minus 8, and if we add, we will get minus 2x. So then, after splitting the middle term, take out the common factors. X square minus 4x, the common is x. Therefore, we can write x minus 4. Plus 2x minus 8, we can take 2 as common. Therefore, x minus 4 equal to 0. Therefore, x plus 2 equal to 0. Or x minus 4 is equal to 0. Therefore, we get x is equal to minus 2 as 1 zeros. And x minus 4 is equal to 0 and x minus 4 is equal to 0, therefore x is equal to 4. So we got two zeros, or we can also say that we got two roots, or we got alpha and beta, which we represent for the roots. Alpha is one root, beta is one root. Or we can say that we have got two zeros, x equal to minus 2 as 1 0, x equal to 4 as another 0. Or we can say that we have got two roots of this equation, minus 2 and 4, which we represent using the symbols alpha and beta. Okay. So we have got two zeros. So we have got two zeros. Which are those? Those are minus 2 and 4. These are minus 2 and 4. And the next thing is, after finding the zeros, we have to verify the relationship between the zeros and coefficient. We have to verify the relationship between zeros and coefficient. So the relation is such that alpha plus beta is equal to minus b by a. So what does alpha plus beta indicate? Alpha plus beta indicates sum of the roots. Alpha plus beta indicates sum of the roots. So what are the roots? Minus 2 and 4. Minus 2 and 4. If we add minus 2 and 4, that should be equal to minus b by a. So what is alpha? Alpha is minus 2. Alpha is minus 2 and beta is plus 4. This should be equal to the minus b by a. B and a are coefficients. B and a are coefficients. So b represents the coefficient of x. A represents the coefficient of x square. So b represents the coefficient of x and a represents the coefficient of x square. So what is b? The value of b is minus 2. The value of b is minus 2. So I can write b value as minus 2 and the a value is 1. So I have written a value as 1. So compare alpha plus beta is equal to minus b by a. The left hand side is sum of the roots and the right hand side are coefficients. Coefficient of that quadratic equation. So what is minus 2 plus 4? Minus 2 plus 4 is 2. And the right hand side minus into minus 2 is plus 2. Divided by 1. 2 by 1 is again 2. Therefore LHS is equal to RHS. That is, the relationship between zeros and coefficients is as such that sum of the roots will be always be equal to minus b by a. Minus b by a. Similarly, there is one more relation related to product of the roots. If I take the product of the roots, that is alpha into beta. Alpha into beta is alpha is minus 2, beta is 4. Alpha into beta will be always be equal to c by a, where c and a are coefficients. C is the constant term in the expression. So in the expression x square minus 2x minus 8. So c, the value of c is minus 8 and the value of a is 1. So in the expression x square minus 2x minus 8, the value of c is minus 8 and the value of x square is 1. So therefore alpha into beta is equal to c by a. Alpha is minus 2, beta is 4, minus 2 into 4 is equal to c by a. C by a is minus 8 by 1. So LHS will be equal to RHS, that is minus 8 is equal to minus 8. Okay. Okay, the next question is 6x square minus 3 minus 7x. We can rewrite this question as 6x square minus 7x minus 3 equal to 0. Okay. So note down the condition. First we have to find the zeros. The value of a is 6. The value of c is minus 3. So if we multiply the numbers, we should get minus 18. If we add, we should get minus 7. If we add, we should get minus 7. If we multiply, we should get minus 18. So which are the two numbers whose sum is minus 7 and whose product is minus 18? So it is simple that minus 9 and 2. If we multiply minus 9 and 2, minus 9 2s, it is minus 18. And if we add minus 9 and 2, we will get minus 7. Therefore, we can split this quadratic equation as x square minus 9x. We can split the middle term as x square minus 9x plus 2x minus 3 equal to 0. Okay. And then we can take out the common factor. 6x square minus 9x, which is the common thing. 6 and 9, common factor is 3. X square and x, common factor is x. Therefore, we can write 6x square minus 9x as 3x into x minus 3. Similarly, 2x minus 3, we can take. Okay, 3 to the 6. Similarly, in 2x minus 3, only 1 is common, therefore we can write 1 as common factor. We can rewrite the remaining, that is 2x minus 3 is equal to 0. Therefore 3x plus 1 equal to 0, or 2x minus 3 is equal to 0. Therefore 3x equal to minus 1. Here 2x is equal to plus 3. Minus 3, if we take on the right hand side, it will be 3. 2x equal to 3. Therefore the value of x can be 1 by 3. Here 2x equal to 3. Therefore the value of x can be 3 by 2. So we have got two zeros here. First we can call it as alpha. Second one it is called it as beta. So the value of alpha is 1 by 3 and the value of beta is 3 by 2. Value of alpha is 1 by 3 and value of beta is 3 by 2. So how did we get these values? By just splitting the middle term. Middle term is 7x. We have split the middle term such that the product is minus 18. That is 6 3s. The product is minus 18 and the sum should be minus 7. Which are the two numbers that satisfy that condition? Minus 9 and 2. So using minus 9 and 2, we have split the middle term and we simplified. We got the roots as 1 by 3 and 3 by 2. Then we have to verify the relation. Verify the relation between zeros and coefficient. The first relation is alpha plus beta is equal to minus b by a. So what is the value of alpha? What is the value of alpha? It is 1 by 3. What is the value of beta? That is 3 by 2. This should be equal to minus b by a. This should be equal to minus b by a. What is the value of b? Minus 7. So what is the value of b? Minus 7. What is the value of a? Value of a is 6. So write down as 6. So 1 by 3 plus 3 by 2, take LCM as 6. 3 2s are 2 3s are 2 1s are 2 plus 3 3s are 9. 9 by 6. Okay. So minus into minus 7 is plus 7. Plus 7 by 6. So this is minus 1 by 3, right? So this is minus 1 by 3. Therefore we will get 9 minus 2 as 7 by 6. So this is also 7 by 6. Okay. So LHS is equal to RHS. So LHS is equal to RHS. Alpha plus beta is again equal to minus b by a. Therefore the relation is verified. Okay. The relation is verified. This is the relationship between the roots of the equation and the coefficient. Or this is the relationship between the zeros and the coefficient. There is one more relation. There is one more relation. As I told you, we can also find out alpha into beta. We can also find out alpha into beta. This is alpha plus beta. We can also go for alpha into beta. Alpha into beta is equal to c by a. Alpha into beta will be always equal to c by a. So what is alpha? Alpha is 1 by 3 minus 1 by 3. Beta is 3 by 2. This should be equal to c by a. C is minus 3. A is 6. Okay. If we multiply, we will get minus 3 by 6. Right hand side, there also we will get minus 3 by 6. So the value of alpha is minus 1 by 3. The value of beta is 3 by 2. Alpha beta should be equal to c by a. This is the relationship between zeros and coefficients. So minus 1 by 3 into 3 by 2. C by a. C value is minus 3. A value is 6. Okay. C value is minus 3. A value is 6. So minus c by a is minus 3 by 6. So the product of the roots is minus 3 by 6. Therefore LHS is equal to RHS. This is the relationship between the zeros and coefficients. This is the relationship between the zeros and coefficient. Here is another question where we have to find the zeros and verify the relation. So how do you find the zeros? we have to split the middle term, that is 2 root 2, so that the product should be minus 6. Product should be minus 6 and the sum should be 2 root 2. The sum should be plus 2 root 2. The sum should be plus root 2 and the product should be minus 6. So we have to split the middle term. So how can we split? X square plus 2 root 2 can be written as 3 root 2 x minus root 2x minus 6. So I have split the 2 root 2. I have split the middle term 2 root 2 as 3 root 2 minus root 2. Because if we multiply 3 root 2 and minus root 2, we will get the answer as minus 6. What is root 2 into root 2? Root 2 into root 2 is 2 and this minus symbol remains here. Minus 3 into 2, that will be minus 6. That will be minus 6. Therefore, the two terms are 3 root 2 and root 2. If we multiply 3 root 2 and minus root 2, we will get the product minus 6. If we add or if we get the sum of 3 root 2 and minus root 2, the answer will be again 2 root 2. So which are the two numbers for splitting the middle term? The numbers are 3 root 2 and minus root 2. So therefore I have split the middle term as 2 root 2 as 3 root 2 minus root 2. So next thing is we have to take out the common factors. X square plus 3 root 2x, which is common, x. Similarly, root 2x minus 6, which is the common factor. Which is the common factor? We can take root 2 as common. We can write x here. And 6 we can write it as 3 into 2. 6 we can write it as 3 into 2. And again this 2 we can write it as root 2 into root 2. So we can write 6 as 3 into root 2 into root 2. Root 2 into root 2 is again 2. 2 3s again is 6. Therefore we can write 6 as 3 into root 2 into root 2. So considering the common factor, so here we have taken, we are taking root 2 as the common factor. So therefore we have taken out root 2 as the common factor. We have written x as it is plus. So out of 2 root 2, 1 root 2 is outside the bracket. We have to write another 2 root 2 inside the bracket along with 3. Therefore the answer in the bracket is x square x plus 3 root 2. X plus 3 root 2 is equal to 0. So the next step is again equating x minus root 2 is equal to 0. Here x and here remaining is minus root 2. X minus root 2 is equal to 0. Or another possibility is x plus 3 root 2 is equal to 0. Therefore x minus root 2 is equal to 0. X equal to root 2. And x plus 3 root 2 is equal to 0. Therefore x is equal to minus 3 root 2. These are the two zeros which we call them as alpha and beta. So take this as a homework and you can verify the relationship between alpha plus beta, that should be equal to minus b by a, and also verify alpha into beta should be is equal to c by a. Verify these relation for these values of alpha and beta. Verify the relationship between zeros and coefficient for these values of alpha and beta. Okay. So the next category is we have to find the quadratic polynomial with the given numbers as sum and product. So in the previous questions, what we have done is they used to give the quadratic equation. They will be giving the quadratic equation. We have to find the zeros and we have to find the sum and product. But in these next set of questions, we have to form the quadratic polynomial and they will be giving the sum and product. So in the previous question, they will be giving the quadratic equation and we have to find the sum and product. But the question here is, it is different. They are giving the sum and product of the zeros. We have to find the quadratic polynomial. So it is very simple. Here they have given us the two zeros, that is value of alpha and value of beta. We have to find the quadratic equation. We can write in this format, that is x square minus sum of zeros into x plus product, that is x square minus sum of zeros indicates alpha plus beta into x, product of zeros indicates alpha into beta equal to 0. X square minus, what is the value of alpha and beta, alpha plus beta? They have given sum as 4, product as 0. They have given sum as 1 by 4, product as minus 1. So write alpha plus beta as 1 by 4. Write alpha plus beta as 1 by 4. And take the value of alpha into beta as minus 1, that is the product. Alpha into beta as minus 1, that is the product. Then simplify. After simplification, take the LCM as 4. Take LCM as 4. Denominator is 4. Take LCM as 4. We can write it as 4x square minus x minus 1 whole divided by the LCM 4 equal to 0. So if we take this 4 to the right hand side, we will get the equation as 4x square minus x minus 1 equal to 0. 4x square minus x minus 1 equal to 0. So these questions, in these questions, they will be giving the sum and product. They will be giving with sum and product, and we should solve using this format, that is x square minus sum into x plus the constant term is product. That is, the standard format is x square minus alpha plus beta into x plus alpha beta. So they will be giving it alpha plus beta and alpha and beta. So just we have to substitute these values in the equation and we will get the quadratic polynomial. Okay. So here is another problem where they have given as alpha plus beta as 0, alpha into beta as root 5. So substitute x square minus alpha plus beta into x plus alpha plus beta equal to 0. So what is alpha plus beta? Alpha plus beta they have given it as 0. So 0 into x plus alpha into beta they have given it as root 5. Then simplify. X square minus 0 into x is 0 plus root 5 equal to 0. Similar question they have given, next question, alpha plus beta they have given is 1 and alpha into beta is also 1. So we have to form the quadratic equation. So how do you form the quadratic equation? By giving sum and product. Simple. X square minus alpha plus beta into x plus alpha into beta. So x square minus alpha plus beta value is 1. So we have write it down as 1. Alpha into beta it is 1. Therefore we are writing it as 1. Therefore the equation is x square minus 1x plus 1. Okay. So in this exercise, like there are two types of problems. One problem is they will be giving the equation and we have to find the sum and product. And the second category is they will be giving the sum and product, we have to find the equation. Okay, this is second type of question. And next type of questions they might ask like this also. These questions might also be asked in the exam. If alpha and beta are the zeros of the quadratic polynomial, f of x equal to x square minus 5x plus 4. Find the value of 1 upon alpha plus 1 upon beta minus 2 alpha into beta. Okay. So first we will find the zeros of the polynomial x square minus 5x plus 4 equal to 0. Okay. So how do you split the middle term? So that if we multiply we should get 4 and if we add we should get minus 5. Which are the two numbers? The two numbers are minus 4 and minus 1. Minus 4 minus 1, if we multiply we will get plus 4. If we add we will get minus 5. Therefore we can split the minus 5 as minus 4 and minus 1. So take out the common factor x, we take out the common factor x minus 4. Minus 1 we take out the common factor x minus 4. Therefore we can write it as x minus 1 equal to 0 or x minus 4 is equal to 0. X minus 1 is equal to 0 or x minus 4 is equal to 0. So if x minus 1 is equal to 0, what is the value of x? X is 1. And if we take x minus 4 as 0, we can write it as x equal to 4. So the value of alpha is 1, the value of beta is 4. So we have found out two zeros. The value of two zeros is 1 and 4. So the first zero I will call it as alpha and the second zero I will call it as beta. So the first value is alpha, the second one is beta. But they are asking me to find 1 upon alpha plus 1 upon beta minus 2 alpha into beta. Okay. So how do you find these? Okay. So simplify the expression which are given 1 upon alpha plus 1 upon beta. The LCM will be 1 upon alpha plus 1 upon beta. The LCM will be alpha into beta. So multiply the LCM. So here alpha, here you should write beta, here beta there is here. We can write it as alpha. So after taking the LCM, we can write it as alpha plus beta divided by alpha beta minus 2 alpha into beta. So after taking the LCM, we can write the given expression as alpha plus beta divided by alpha beta minus 2 alpha beta. So next we have to find we have to find the value of alpha plus beta and we have to find the value of alpha into beta. So simple. What is alpha plus beta? So alpha is 1, beta is 4. Alpha plus beta is 1 plus 4 is equal to 5. What is alpha into beta? Alpha into beta is multiplying the products 1 into 4. That is 1 into 4 is 4. So alpha plus beta is 5. Alpha into beta is 4 minus 2 into alpha beta. Minus 2 into alpha beta is 4. So the final expression is 5 by 4 minus 8. 5 by 4 minus 8. Take out the LCM. 1 4s. Okay. So something like 5 minus 32 by 4. So the final answer is 5 minus 32 by 4. That is minus 27 by 4. That will be the final answer. Okay. So these type of questions might also be asked in exam, which are not given in textbook, but we have to refer some other reference books like R.D. Sharma or R.S. Agarwal or any other book, and you have to practice such questions if you are writing for a CBSE board exam. Okay. So here is a similar question. Here is a one more similar question. Okay. You can try this. 5y square minus 7y plus 1 and find the value of 1 upon alpha plus 1 upon beta. So 5y square minus 7y plus 1 equal to 0. So if we multiply 1 into 5, the answer is 5. Therefore, the product should be 5. And the sum should be minus 7. Product should be 5 and the sum should be minus 7. Product should be 5 and the sum should be minus 7. Which are the two numbers? The product should be 5 and the sum should be minus 5. Minus 7. So there are no two numbers. We are not getting those two numbers. Where we can split the middle term using that condition. In that case, what we can do is 5y square plus 7y plus 1. In that case, what we can do is we can go for sum and product. What is the sum of the roots? That is alpha plus beta. That will be equal to minus b by a. What is b? 7. What is a? 5. So what is minus 7 by 5? It is minus 7 by 5 after simplification. And what is the product of the roots? Product of the roots is alpha into beta. What is alpha into beta? Alpha into beta is again equal to c by a. What is c? The value of c is 1 and the value of a is 5 and the value of b is 7. So alpha into beta is equal to c by a. The product of the roots is equal to c by a. C value is 1. A value is 5. The answer is 1 by 5. So we got alpha plus beta is equal to minus 7 by 5, and alpha into beta is equal to 1 by 5. Alpha plus beta is equal to minus 7 by 5. Alpha into beta is equal to 1 by 5. So by using these two, we can find the value of 1 upon plus alpha, 1 upon beta. They have told us to find 1 upon alpha and 1 upon beta. So how can we find 1 upon alpha plus 1 upon beta? So take the LCM, 1 upon alpha plus 1 upon beta. After taking LCM is alpha into beta. So after taking the LCM, we can write it as, here we can write it as beta, here we can write it as alpha. So here alpha is there, we can write beta, here beta is there, we can write alpha. Therefore beta plus alpha divided by the LCM alpha into beta. So the given expression 1 upon alpha plus 1 upon beta, the given expression 1 upon alpha plus 1 upon beta, after taking out the LCM, we can write it as beta plus alpha divided by alpha into beta. So now the value of beta plus alpha, we have found out it as minus 7 by 5. Substitute in numerator where the value of alpha plus beta, and the value of alpha into beta is 1 by 5. Substitute in the denominator. So 5 got cancelled. 5 got cancelled. The remaining is minus 7 by 1. Minus 7 by 1 is minus 7. So this is the value of 1 upon alpha plus 1 upon beta. Okay. So this is a simple question. Similar questions might be asked in your exam. So better prepare some difficult questions from R.D. Sharma book or R.S. Agarwal book or any other book or any other question bank, as the CBSE might ask questions other than the questions which are given in the textbook. Okay. Hope you have understood this chapter polynomials. There are many variety questions to be covered, which will be covered in the next class. Okay. Thank you.